Hey guys, good morning. In rocket and missiles, today we are going to see on case study on ISRO, so Scramjet engine technology. So what about the ISRO Scramjet engine technology? So the flight with critical technology such as the ignition of the air-breathing engine at supersonic speed, holding flame holders at supersonic speed, air intake mechanism and fuel injection system has been successfully demonstrated by ISRO. The Scramjet engine is designed by ISRO used hydrogen as a fuel and oxygen from the atmospheric air as oxidizer. So the main thing is they're using atmospheric air as an oxidizer, right? So in August 28, test was made a short duration experimental test by the ISRO. ISRO Scramjet engine with the hypersonic flight testing of Mach 6. The ISRO Advanced Technology Vehicle ATV, which is an advanced sounding rocket. This solid rocket booster used for recent test of Scramjet engine at supersonic condition. This diagram indicating the design of the supersonic Scramjet engine, and they have the sharp leading edge and tailing edge, no rotating parts, right? So what is a satellite launch vehicle? Usually the satellite launch vehicles are into orbit by multi-staging satellite launch vehicle that can be used only once. These launch vehicles carried oxidizer along with the fuel of combustion to produce a thrust. Launch vehicle designed for one-time use or expensive, and then their efficiency is low because they can carry only 2 to 4% of lift-off mass to the orbit. Thus, there is a worldwide effort to reduce the launching cost. Nearly 70% of the propellant, that is fuel and oxidizer combination, carried by today's launch vehicles consist of an oxidizer. So the major is oxidizer is 70%. Therefore, the next generation launch vehicle must be a propulsive system which utilizing the atmospheric oxygen during their flight through the atmosphere, which considerably reduce the cost and total propellant required to place a satellite in a orbit. So also if those vehicles are made by reusable concept, and the cost to launch the satellite will further come down significantly. Thus the for future reusable launch vehicle concepts along with the air-breathing propulsion is an existing candidate offering routine access to space at far low cost. So considering this strategy nature of air-breathing technology, which has the potential to bring a significant shift in the launch vehicle design, worldwide effects are on the developed the technology as air-breathing engine. The Scramjet, Ramjet and dual mode Ramjet are the three concepts of air-breathing engine which are being developed by various space agencies like NASA, ISRO, SpaceX and so on. This Ramjet is a form of air-breathing engine that uses the vehicle forward motion to compress incoming air for combustion without a rotating compressor. Fuel is injected in the combustion chamber where it is mixed with the hot compressor air and ignites. A ramjet powered vehicle requires assisted takeoff like a rocket assist to accelerate into a speed where it's being to produce a thrust. So this ram powered vehicle will not automatically directly fly. So we need a additional assistant which take off the like rocket motors. So we have to fix in a missile or in a launch vehicle as a ramjet power, and we have to use this ramjet work more efficient at supersonic speed around Mach 3. This is 3 times of the speed of sound and can operate up to Mach number 6. So ramjet, however, more efficient and starts drop down when the vehicle reaches the hypersonic speed. So ramjet will operate effectively in Mach 3 to Mach 6. So if it reaches the hypersonic, then efficiency will start drop. So that's why we are moving on. Another engine is called a Scramjet engine. Scramjet engine is an improvement over the ramjet engine as an efficient to operate at hypersonic speed and allow supersonic combustion. Thus the dual mode ramjet is a type of jet engine where a ramjet transforms into a scramjet. So over a Mach number, range width is 4 to 8, which means it can efficiently operate both a subsonic and supersonic combustion mode. So both combustion take place in subsonic and supersonic cases. An important development in the ISRO was Air Breathing Propulsion Project ABPP occurred on August 28, 2016, which was a successful flight test by the ISRO of its Scramjet engine. The first experimental mission of ISRO's Scramjet engine towards the realization of the air breathing propulsion system was successfully conducted from Satish Dhawan Space Center, Sriharikota, India. Right. So the flight test after the making of this on the flying vehicle, after a smooth countdown of 12 hours, the solid rocket boosters carrying the Scramjet engine lifted off morning 6 a.m. Indian Standard Time. So the important flight event, namely the burn out of booster rocket stages, ignition of second stage is solid rocket. The function of Scramjet engine of 5 seconds followed by burn out of second stage took place exactly what ISRO's planned. After a flight about 300 seconds, the vehicle touched down the Bay of Bengal, approximately 320 kilometers away from the Sriharikota, which is that the maximum flight time is 300 seconds and the Scramjet engine functioning of only 5 seconds. That is a huge achievement of the initial stage of the ISRO, and the vehicle was successfully tracked during the flight from the ground station Sriharikota. So all the starting to ending condition, all are pre-programmed and they have tested in 5 seconds. Everything is tracked during the flight from the ground station Sriharikota. With the flight, the critical technologies such as ignition of air breathing engines at supersonic speed, holding a flames at supersonic speed, air intake mechanism, fuel injection system have been successfully demonstrated by ISRO. The Scramjet engine designed by ISRO used hydrogen as a fuel and oxygen from the atmosphere as an auxiliary. The flight test at Mach 6 Mach number, ATV technology is used, and the side boosters are used for the Scramjet engine supersonic condition. AVT carried, that means advanced technology vehicle carrying Scramjet engine weighted of 3,277 kilo at lift-off condition. This is the advanced technology vehicle diagram, which is having nose cone and fuel feed system, sustainer, that Scramjet engine and boosters, which is the 10.3 meters of height, total height. So India is the fourth country to demonstrate the flight test of the Scramjet engine. This ATV, that means advanced technology vehicle, which is different from the advanced technology vessel. The advanced technology vessel is completely different from the advanced vehicle. Advanced technology vessel is a nuclear power attack submarine project defense, which is using DRDO, and BARS, Indian Navy, and public sector and private industry, which is using advanced technology vessels. So ISRO using advanced technology vehicle for to launch the launch the missiles or rockets or launching the satellites. The ATV is a two-stage spin stabilized launch, which identically solid motor based on the, we are taking this from the Rohini's RS-560 rocket as the first as well as the second stage is boosters and this sustainer. In twin ramjet engine were mounted on the back of the second stage. They are fixing this twin stage ramjet engine as in this in sustainer, that means in second stage. Once the second stage reaches the desired condition of engine, the startup necessary action were initiated to ignite this Scramjet engine, and they functioned about 5 seconds. ATV for flight operation were based on the pre-programmed sequence. Everything is pre-programmed before the flight, right? Next is this is the flight path test, and initially the boosters are ignited and launching of the missile, and the Scramjet was attached. And once the first stage fuels are burned out, then separation take place of these both Scramjet and the launch vehicle. Launch vehicle get dropped in Bay of Bengal, and the ignition of the Scramjet will take up the 5 seconds, and Scramjet ignition ends off in cruise condition, and it lift down to the sea of Bay of Bengal. This is achieved to the 5 seconds of flight using hypersonic speed. What are the technology challenges made by the ISROs during the Scramjet engine design and development in hypersonic condition. First one is they have made the air intake challenges, especially the air intake must come into the combustion chamber with supersonic. It should combustion take place in supersonic. That's one of the major challenges made by the ISRO. Second one is supersonic combustion. The combustion should take place in supersonic speed. Then development of material withstanding very high temperature. So the designed material of the entire scramjet engine should be withstand with high temperature. And computation tools to simulate the hypersonic flow. The major thing is before the testing or the experimental test, they have to make the computational tool to simulate the hypersonic flow. That is one of the major challenges made by the ISRO. Ensuring performance and operability of the engine across the wide range of flight speed and proper thermal management system. And the ground testing of the engine is the another technology challenges made by the ISRO. So what are the applications we can make it of is? One is a military application, one is civil application. Military application, we can use this supersonic combustion engine in a long range cruise missiles to launch the missiles in the long range. Second one is a civil application, launching the satellites at low cost. It helps us to launch the satellites in the orbit in very low cost. Why? Because we are using auxilizer from the atmosphere, right? So this helps us to India to support the other nation to launch their satellites in the orbit, right? So so far we seen the ISRO's Scramjet engine technology used for the future application, and we'll see the another case in upcoming weeks. Thank you.